Welcome back to geometry. Let's continue with chapter 18. This will be the start of section 18.3. The first day we're going to talk about pyramids, but first let's do our warm-up and find the surface area of this prism. So I'm going to start with the top and the bottom. I'm going to do in red here. The bottom and the top are both 4 by 5, so we have two 4 by 5 sides, plus the right side here is 4 by 10, and so is the left side. So we have two 4 by 10 sides. And then finally the front and the back. The front is going to be 5 by 10, and the back will also be 5 by 10. So we have two of those. So 4 and 5 multiply to 20. We double 20 and we get 40. Here we're going to multiply and get 40, and we're going to double that and get 80. And then here we'll multiply that and get 50, and we'll double that. And if we add those up, we get 220. And do not forget your units. We were talking in feet. And since it's area, that is feet squared. All right, warm-ups in the book. Let's talk about surface area of pyramids. A little fill in the blank. A regular pyramid is a pyramid whose base is a regular polygon, all sides same, all angles congruent, whose lateral faces are congruent isosceles triangles. The slant height, they use this cursive-looking letter L. The slant height L of a regular pyramid is the height of each lateral face. All right, here in example 1, pretty easy. How many congruent lateral faces does each pyramid contain? Well, it's going to have one lateral face for each side of the base. So in a square, our base is a square. A square has 4 sides, so we will have 4 lateral faces. A triangular pyramid. The base is a pyramid, or a triangle, excuse me, and a triangle has 3 sides, so that will have 3 lateral faces. Our last one is a hexagonal pyramid. A hexagon has 6 sides, so we will have 6 lateral faces. Example 2. Consider the regular square pyramid as shown. First, this L here, a lot of people in class the first time I taught this thought it might have represented this edge right here, but that's not what it is. I'm going to amend this in the notes, draw a little arrow. L is this right here. That's sliding up or down the face of that pyramid. So how is the slant height different from the height of the pyramid? Again, this slant height here, it is perpendicular to this edge of the base. But if I were to draw the height of the pyramid going down the middle of the pyramid, that is perpendicular to the base. And our slant height is not perpendicular to the base. So that's what I'd write for part A. It's not perpendicular to the base. It's not perpendicular to the base. All right, now for part B, not kind of enough room left in here. I'm going to sort of draw it down below. Sketch the net for this pyramid. Well, I'm going to draw first the square base. So looking down on it from above, we're going to have a square base. And the side is going to be S, and this side is going to be S. And now, off each of those sides, I'm going to have one of these lateral faces, and each lateral face is a triangle. So there'll be a triangle sort of on top of this square, one over here on the right side, one on the bottom, one on the left. And then I'm going to draw in here a little dotted line, and that would be L, that lateral length. So there's our net, the sketch of the net. And now they want us to come up with a basic, a general formula for the surface area of a square pyramid. Well, let's start as simple as we can get. Surface area equals, of a square pyramid, we're going to have one square, that's the base, and then a square has 4 sides, so we're going to have 4 triangles. All right, well, in our picture here, they're calling the side length S, so our square will be S times S, or S squared. And then we're going to have 4 triangles. Now, each triangle is 1/2 base times height. Well, in the picture, here's my base, and that's S, and then the height of the pyramid will be L. So our formula, 1/2 S times L. All right, so there's our general formula, the base squared, or S squared, plus 4 triangles. Now, suppose the side length S is 7 and the slant height is 5. Use our formula to come up with the surface area. So I'm just going to rewrite that. What was it? Surface area equals S squared plus 4 half S times L. So S is going to get turned into a 7, so this becomes 7 squared plus 4 times, and now our area of a triangle is going to be 1/2. S, again, is 7 times L, which is 5. Boom. So 7 squared, that's 49, plus half times 4, that turns into a 2. 2 times 5 is 10. 10 times 7 is 70. Add those together, and we get our surface area is 119. Our units are centimeters. Centimeters squared. Excellent. Example 3, we now have a more complicated pyramid, hexagonal pyramid as shown. All right, let's see, part A. Can we generalize the formula we wrote for the surface area of a square to find the surface area of a hexagonal pyramid? If so, write the formula. If not, what additional information would we need? Well, in the square one, it was easy to find... It is easy to find the area of the square base. That's just side times side. In this case, we have a regular hexagonal pyramid. So what we're needing here that we don't readily have, we need the area of the base. Need area of the base. Now, we could sort of come up still with a formula. We could write SA, the surface area of the hexagonal period, equals area of base plus, now we're going to do our triangular sides. We've got 6 sides in a hexagon, and each side is going to be a triangle. And our triangle are going to be 1/2, and the base, they're using S again. And the height of the pyramid here is L. The length of that lateral side is L. So we could use that formula if we knew what the area of the base was. And then part down there below it says B, describe the general formula for the surface area of any regular pyramid. So it's going to be similar to what we just did. Our surface area will be area of base, and that will depend on what regular polygon our base is. But if we can find the area of the base, we're going to add. Now we're going to call it, let n equal number of sides. N equal number of sides. So we're going to have n, the number of sides, times our triangle area formula, 1/2 S times L. All right, and that'll work for anything as long as we know the number of sides and can figure out the area of the base of that regular polygon. Some more fill in the blank. Surface area of a regular pyramid. The lateral area of a regular pyramid with side length S and number of sides N and slant height L is, we saw this already, N times 1/2 S times L. The surface area of a regular pyramid with lateral area L and base area B. Now they're calling the lateral area total L, so we could write it as B plus L. B is just the area of the base. L is the lateral surface area, or we could turn this back into a formula similar to what we had before. B plus, that's the same B plus as we see here. We would just take out our lateral formula, that capital L, and replace it with the good old N times 1/2 S times L. Number of sides in our base, and then there's the area for the triangle of each side. All right, example 4. Find the surface area of the pyramid, round to the nearest tenth if necessary. So our surface area. And because it is a square, your note should have square in there. I don't think it made it into mine. So we're going to do the side length squared. That'll be the area of our base. A square has 4 sides, and each side will be a triangle, and that will be our 1/2 S times L. All right, let's start plugging stuff in and see how it goes. Surface area equals. Our base is nice. Our square is a 4 by 4. So S squared is going to be 4 squared plus 4 times 1/2 S, that's easy. That's right here. That's 4 times L. Uh-oh. Look at the picture. Here's L, and we don't have it. So we are going to have to solve for that. Luckily, this is a right triangle we can see down there at the bottom. So I'm going to sort of copy that inner triangle out here. And let's see, this is labeled as 7 feet. Now the entire side here is 4, and this would be exactly half of that. So down here is a 2. And now we're going to find our missing hypotenuse, which we usually call C, with Pythagoras. 2 squared plus 7 squared equals C squared. 4 plus 49 is C squared. 49 and 4 add up to 53 is C squared. And if we take the root, let's not do a decimal yet. Let's keep it as root 53. So there is the lateral length of our triangle sides. Let's put it right in here as a root 53. Okay, 4 squared, that's easy, that's 16, plus, if we do this in pieces, half of 4, that's equal to 2 times this 4. 2 times 4 is 8, and then we got our root 53. Now, I think this is real easy to put in the calculator. I would do the root 53 first. You'll get a decimal, multiply that by 8, and then plus 16, and you should get surface area is approximately 74.2. 74.2. Our units are feet, and that will be feet squared because we're talking area. All right, let's take a break from the examples. Let's do a couple practice problems, and then we'll wrap up with one more example. So this is a good spot. Pause the video. Try these 2. I think we got one here. So there's 3 practice problems to do, and then start the video back up and see how you did. Okay, in the first one, our surface area equals, now it's a square base, so we could do side squared, plus we're going to have 4 sides. Each side is a half S times L. Okay, surface area equals our base side. Each side is 9, so that's going to be 9 squared, plus 4 times 1/2 S is equal to 9. Once again, we're going to have to solve for that L. So I'm going to sort of draw a little right triangle over here. This height is 5, so this is 5. This entire side length is 9, so this is going to be half of that, 4.5. And hypotenuse, we'll just call it C, as we usually do. So we're going to have 5 squared plus 4.5 squared is C squared. If we square those and add those together, you should get 45.25 is C squared. And once again, let's leave that as a radical for now, root 45.25. So I'm going to move this parenthesis. I might need a little more room. And we're going to put in it times our root 45.25. All right, if the button pushing on your calculator goes well, the surface area should be about 202.1 feet squared. Excellent. All right, letter B. They're kind of making this easy on us for letter B a little bit. Surface area is equal to, remember what we did, area of base. Surface area is the area of the base, plus the number of sides of our base times our area of a triangle, half S times L. Now, what made this one a little easy, area of the base, they give it to us right here. They got that little arrow pointing. The base is 110 inches squared. So that's already the completed area. And we're going to add to that. We have here a pentagon. Pentagon has 5 sides. And we're going to multiply that by 1/2. Our side here, they say, is 8 inches. Times 8 times. And here they gave us L. We don't have to use Pythagoras to solve for it here. That's just an 11. 11. So let's see. We've got 110 plus half of 8 is 4. 4 times 5 is 20. And then we multiply that by 11, and we get 220. 110 plus 220 is 330. Our units here were inches, and that will be inches squared. All right. One more. Find the surface area of the figure. If necessary, round to the nearest tenth. Notice we've got a pyramid on top of a square-based rectangular prism. So when we're finding the surface area of the rectangular prism, we are going to need to find the bottom of this, but the top of it is going to be covered by the pyramid. So this is going to be kind of like the warm-up, but we're only going to need 5 sides instead of 6. So let's see, right here, surface area. Let's do the base first. The bottom of that box is 12 by 12. And we only got one of them, so that will not get multiplied by 2. And then we're going to have plus 4. Now, notice each of these sides is going to be the same. This side is 5 by 12. This side is 5 by 12. And around the back, this side is 5 by 12, as is the back of the box. So we're going to have 4 5 by 12 sides. So that's going to take care of this base. And the base of the triangle on top, the pyramid, that's going to be, sitting on the top of the box. So that's not part of our surface area. So now we're going to have 4 triangles. We are going to have to do a little work on the triangle now that I look at this. Let me switch to red ink. Somewhere here in the middle, we would have our height of our triangle. This entire length is 12. The prism by itself here is 5. So if we subtract 12 minus 5, this is going to be 7. And then if we connect that here to this edge, it's going to be half of this. That's 12. So this is going to be 6. So we will have to use Pythagoras to find this side I'm marking C. 6 squared plus 7 squared equals C squared. That is 36 plus 49 is C squared. C squared is 85. So C equals root 85. So our triangle, we're going to have 4 triangles. Each area of those will be a half times the base, 12, times the height, root 85. So let's see here, 5 times 12, that's 60. 60 times 4 is 240. 12 times 12 here is 144. And then here, half of 4 is 2. 2 times 12 is 24 times root 85. And if your calculator button pushing went well, the surface area here is approximately 605.3 feet squared. All right, so that was a little practice there in the team huddle. I think we got one more example. Yeah. Applying a formula. Recall that population density is the number of organisms of a particular type per square unit of area. Surface density is similar in that it is the number of objects per square unit of area. We can find the surface density by dividing the number of objects by the area of the solid. So we got somebody here, Evan. He's decorating a crystal square pyramid paperweight. He has a bottle of 250 gold flakes to cover the paperweight. He covers the pyramid with glue and rolls it in the flakes, making sure all the flakes in the bottle have stuck to the pyramid. What is the surface density, the number of gold flakes per square centimeter? All right, part A. Let's find the surface area of the pyramid. And square pyramid paperweight. So our surface area is going to equal base squared. Here's our base side, that's 2.5. So we're going to have 2.5 squared plus, we're going to have 4 triangles. And our triangles are 1/2 times the base 2.5 times the lateral length there, 3.5. Oops. So if we punch that in on our calculator, we are going to get 23.75. Let's do that. The 2.5 squared, that's 6.25. Plus the other component there is going to be 17.5. And that turns out to be 23.75 centimeters squared. All right, so we got the surface area. Now it says calculate the density. Well, they said earlier the density is the number of things. Here it is 250. They were gold flakes. I'm just going to call them flakes. So there's our total amount of those, and then we're going to divide it by the available surface area, 23.75 centimeters squared. So if we do that division, and let's take this out to as many decimals as we can, I took it out to 10.5263. Now our units are going to be numerator units per denominator units. So this 10.5 is flakes per centimeter squared. So every square centimeter is going to have between 10 and 11 gold flakes on it. All right, now the trickier one. How many flakes would be on one of the triangular faces? Explain how you found your answer. Now, there is a more difficult way to do this, and there's an easy way to do it. Let's do it the easy way. We know we have 4 triangular faces, and each triangular face is right here in red. 1/2 times 2.5 times 3.5. So I'm going to write area of one triangle. So again, that area is going to be 1/2 times 3.5 times 2.5. And if we multiply those together, we have 4.375 centimeters squared. So if each triangle has this many square centimeters, and each square centimeter is going to have that many flakes, we're just going to multiply them together. 4.375 multiplied by 10.5263. And that turns out to be approximately 46.0526 flakes per triangular side. All right, that was kind of fun. All right, this is an example. This is a practice problem for you. Out in Las Vegas, there is the Luxor Hotel. It looks like a pyramid from Egypt. It is a square pyramid with a height of 350 feet. So the first thing they're at, well, of course, you should pause the video. You should already have this all done before you're listening to me solve it, right? You did solve it already. What is the slant height of one of the faces? All right, well, let's do this. We're going to sort of look into the pyramid like this. And they told us the height is 350. And then the bottom part of this triangle is going to be half of this number right here, the 646. So let's cut 646 in half. That's going to be 323. So here, once again, we're looking for the hypotenuse C. So you should have done, I should have done this up here, 350 squared plus 323 squared equals C squared. Here, we're not going to leave it as a radical. We'll get a decimal. So what we should have got here, our C squared, I guess we could have called it L squared, was going to be 226,829. And then we're going to take the square root of that, and we get about L is approximately 476.266 feet. And let's just round that off to a nice 476. We can go to the nearest foot in this one. All right. Now in the next one it says lateral area of the pyramid. Remember, lateral area just excludes the base. So we don't want to worry about the base at all. So the lateral area of the pyramid is just going to be our 4 triangles. So we have 4. Yes, that'll be 4, and then area of each is going to be 1/2. And then our base is the 646. And then the height is the L we just found, the 476. And then for the calculator, here 1/2 of 4 is 2. 2 times 646. Multiply that by 476. And you should get 600. Let me erase this so I could write it in there. Boop. 614,992. And that would be units feet, and they would be squared feet. All right. Now somebody built a model of the hotel, and on the model, 1 inch squared is 1,000 feet squared in the real thing. So to the nearest square inch, what is the surface area of just the model? So let's take the 614,992 we just found in part B. That's feet squared. And we're going to just divide that by 1,000. Boom, boom, boom. So that's as easy as we're going to move the decimal over 3 spots. 1, 2, 3. So 614.992. 614.992. And then it does say to the nearest square inch. So let's round that up. That's going to round up to about 615 inches squared. Alrighty, that's the last slide in the slideshow. That's our last practice problem. I'll see you in class.